And welcome back to Connect and Collaborate. I am Alex Hopkins, your host today. And, always, actually. This is a new position for me. I am taking over for Tammy Schaefer permanently. She has moved to Seattle, and we're very happy for her. That is the first time I've said that on air. But welcome back from the commercial break. And we are talking aerospace this week. Right now, we are hosting the Citizens for Space Exploration event. It is very exciting for us. And right now, we have Rob Chambers. He is the Director of Strategy and Business Development for Human Spaceflight, which sounds amazing. Welcome,
it
Rob.
is. Thank you so much for having us here today, Alex. Appreciate it.
Thank you. So, in a few minutes, actually, after we're done here on the radio show, we are going to get to hear a little bit about your background out there. But you know what? I've got a captive audience right now. If you would like to give us your background and tell us about how you got involved with Lockheed Martin.
Absolutely. So I work in the human spaceflight. I've had that bug since I was a small kid. I missed the Apollo landing by about 6 months.
Oh.
So I've been bitter about that ever since. So wanted to jump in and help get us, frankly, on past the moon and on to Mars. So I've been with Lockheed, now for almost 25 years.
Wow, congratulations.
My quarter of a century anniversary comes up in 2 months. Hard to believe. And so I've worked actually in a lot of parts of NASA's aerospace world. So some of the remote sensing, some of our weather satellites, deep space probes, commercial, and even, of course, the space shuttle. But for the last half of my career, last 12 years, I've been here in the beautiful state of Colorado. I grew up in Indiana, but I got here as fast as I could. Is that the same?
Where in Indiana?
South Bend.
Oh, okay, lovely. I went to Ball State for a bit.
Oh, you did? Okay.
I did.
Excellent.
So I'm familiar with South Bend.
I grew up in Irish country, but went to Purdue.
Ah.
But large families, so we covered all the schools.
Yeah,
so
there you go. Boiler up, though.
Exactly, and they're doing pretty well in the attorneys. So I've been here about 12 years and been with Orion that whole time. A bunch of pretty deep technical stuff, controls, guidance and navigation, flight software. But now I have what I think is probably the coolest job on the planet, which is business development and strategy for human space flight just writ large. So we're building Orion, we're building the launch vehicle, and we can talk a little bit about that. But what are we going to do with those? How are we going to unlock the secrets of the solar system? That's what makes me tick.
Oh wow, that's so exciting! I'm thrilled to learn about that. And for human spaceflight, and obviously we've been going to space for quite a bit now, right? We had the moon landing, but I feel like aerospace got lost a little bit. And I know there was a little bit of tag and legislation about whether we should fund NASA and things like that.
That's right. It's kind of exciting. Someone asked me once, what gets me up in the morning? And I said usually my kids because they're hungry, but from a less literal perspective, we're at this cusp. We're kind of like standing on a cliff with our jetpacks on, ready to finally jump off. So you hit on it. We did the moon landing, did that little bit of lunar exploration, and then we kind of retracted. We started eating our vegetables, in other words, so we learned what we needed to learn in low Earth orbit. But now we've mastered some of those capabilities, and we're ready to start expanding out in a way that's maintainable, that's got an infrastructure to it. So it's very exciting. And we were talking about legislature and congressional support. You got to follow the money, right? And so over the last year, some really awesome development. So there was what they call the NASA Authorization Act of 2017. And there's not too many things that all of our government agrees on, but it was unanimously passed by both houses and signed by the president. And it basically said, thou shalt get thyself to the moon, and then thou shalt figure out how we're going to get on to Mars by 2033.
Yeah.
Which, for a lot of our listeners, that seems like a long time. Within aerospace, that is around the corner. That is like tomorrow, it feels. So that's pretty exciting. And then there was a presidential directive at the end of last year that basically reiterated that with clear direction to NASA. So there's momentum building, support, the funding is there, and the hardware is well on its way to start flying.
Yeah, that's fantastic. I love this. One of the things that I never thought would be real in my lifetime at all would be landing on Mars.
Oh yeah, absolutely. It's in my mind, there's no question it's going to happen. My personal goal is before I retire to see that we're in Mars orbit. And then within just a couple of years after that, we've got the capabilities then to do that first landing. And it's always been 40 years out, whenever you look in history, right? And now it's like within a decade or a decade and a half, and that's just astounding.
Yeah, I remember sitting around the kitchen table when I was little with my dad. You know, he got to see the moon landing, and he talked about it a lot, and it was something that I grew up, you know, being inspired by, right? The moon, and then all of a sudden I was like, we'll never get on Mars. I mean, we're never going to have flying cars. How are we going to get on Mars?
When you're eating all your vegetables, learning how to live and work in low Earth orbit, it seems like dessert's a long time away, but now they're serving the dessert course here pretty quick.
Fantastic. And so I would like you to dive a little bit deeper into your title here. Mm-hmm. So strategy and business development for human spaceflight. But how did that... Did they create that for you? Because I've never heard that title.
Yeah, sort of. So, you know, I spent a number of years, like I said, really working that technical detail and control systems and all that. And then about 3 years ago, I started working with the program office. How were we going to take this Orion vehicle that we've been developing for the last decade with NASA, arm in arm? We're done developing. We are now at the point where hardware is being manufactured, and in fact, most of the hardware is already manufactured, and we're testing it and getting ready for flight. So how do we take that and move into a production? So I have a lot of colleagues on JSF, the Joint Strike Fighter, right? Lockheed Martin down in Aero, and they talk about their fleet of 3,000 aircraft. And I say, well, our fleet's more like 6 to 12 spacecraft, but it's still a fleet. And how do you get into kind of the mass production, build to print, the same thing over and over to drive your production costs down so that NASA has funding that we can then go and start developing habitats and landers. So it sounds a little dry, but it was very fascinating.
Yeah.
So I did that for a couple of years, and then we said, good, we sort of have that figured out. Now what are we going to do with Orion and SLS? And so my job is to work with NASA to help figure out what are these missions going to look like, what should the architectures be, and of course all of the different companies are doing that with NASA. So it's a lot of fun. It's almost a community of architects and developers that are working with NASA to now start the actual. We're done designing the tool. Now let's go use the tool. Let's go use the spacecraft.
Wow, that's so fascinating.
Yeah.
So, Rob, you've been with Lockheed 25 years.
That's right.
Yeah, 12 of those here in Colorado. This is more of a personal question. You can tell me that you don't want to answer this.
Take the fifth, yeah.
Yeah, exactly. But Colorado's pretty awesome for aerospace, right?
It is. You know, we've got, if you look across Orion and SLS, so just for any of the viewers that aren't, or listeners that aren't aware, virtual viewers, I'll paint a picture for you. So we've got three main pieces of the system we're building up. And I'll get to your question. I'm actually not dodging it.
No.
So we've got the launch vehicle, the Space Launch System, which we call SLS. Everything's acronyms in our world.
Yes.
Biggest rocket ever built, bigger than Apollo, or bigger than Saturn. Just an incredible machine. That's going to be our ride to orbit. And then Orion it looks a little bit like Apollo, but I tell you, mainly because physics hasn't changed, so the shape still needs to be the shape it was in the 60s. But when you crack the hood on this thing, it's not your grandpa's Apollo. It's got gigabit Wi-Fi, 4 flight computers, it's a glass cockpit, pretty impressive stuff. And then the last element of this is the exploration ground system, and that's the launch pad and the vehicle assembly building we're going to use, and the crawlers, just like you saw with Saturn and Shuttle. So you put all that together, there are over 200 small businesses here in Colorado that are working on those programs, and well over 1,000 jobs just in Colorado working all that. Half of the programs funding really goes straight to small businesses across the country. So, you know, in terms of a place to be, Colorado aerospace and the vibrant economy that's developing is just astounding.
Fantastic.
There's too many people moving here from Texas, which is what I did. So we're trying not to tell everybody that it doesn't actually snow 24/7.
Right. It's hard to keep that up. I think more and more people are realizing our over 300 days of sunshine.
Yes.
Yeah, and don't worry, this is just a Colorado audience.
Oh,
so
thank
they
goodness.
already know.
It does not tell anybody.
Right? The skiing here is terrible. It's so expensive. But that's one of the things that I don't think I realized, because again, not a native. I lived in Indiana. I grew up in Kentucky as well. And so one of the things that I didn't know about Colorado at all is how big the aerospace industry is.
Absolutely. I think, and some of our colleagues can give us the exact quotes, but per capita, it's the largest number of aerospace personnel within by capita within of all the states, even of California and so forth, right? They have maybe more by sheer number, but in terms of the percentage of the people living here that work aerospace, it's the greatest in the country.
Yeah, absolutely. Well, and that being said, we're still number 2 in aerospace, not per capita, right?
Right.
In the country.
Yes.
And I believe it's California that we're behind, isn't it?
I believe so, right.
And well, that's only because they have the coast where they can launch rockets.
Yeah,
It's a little tougher for them.
Vandenberg does help out, right? Yes.
Exactly. But one of the things that we have touched on, at least with every guest that I've had on all week, is the amount of jobs that are tied into aerospace, right?
Absolutely.
You don't have to be an astronaut to get into the aerospace industry.
You know what's so funny, and of course my passion is human spaceflight, but it's pretty representative of where things are heading. It used to be, when we talk about rocket scientists, they were all, mechanical engineers and propulsion engineers and so forth. And then there were the smart eggheads that were developing the trajectories on the ground, right?
Right.
Well, now so much of that has moved into software and flight software that's on board. So there's a whole new discipline of capabilities and jobs that are intrinsically tied to aerospace. And when you look at human spaceflight in particular, and you talk about long duration missions, this is where it gets really exciting. And, so we always hear about STEM, and some people talk about STEAM, where A is for arts, but you can also say A is for any other degree.
Really? Well, and I just want to reiterate here for our listeners, STEM, because not everyone knows this. It's science, technical, engineering, and math careers. And those are, first of all, we're hurting across the country.
Absolutely.
And STEM careers. We need students to take those roles.
Recruiting is so tough, and it's fun. I do these types of, so my day job is to business development, but my fun job is doing like what we're doing here, getting out and talking to people. And I love going to universities because you describe what we're doing, and afterwards, all of these young people, the Gen Edge, which are just starting, and the millennials, which are in full swing, they're just running up with their resumes. Yeah. They're like, I want to devote my life to this kind of work. And so the inspiration of space exploration and some of this is really powerful. And so NASA serves a great function for the country in that regard as a pull. But we were talking, it goes beyond just the traditional technical degrees. When you think about sending humans, a Mars trip is going to be about 3 years round trip. About a year to get out there, a year in orbit, and 6 to 9 months to come back. That's a long time. Now you're starting to think about food processing, and you figure the food has to be up there and the water has to be up in Earth orbit before we leave for Mars, right? So what's the expiration date on bottled water? Well, 3 years is sort of the recognized standard.
Right.
So, how do you keep that potable water, that drinkable water? So food processing, then of course there's the psychological aspects, the health and medical.
Right.
And these folks, let's say you have a team of 4 or 6 people. If someone gets appendicitis, you're operating there, right? Yeah. And so virtual reality and the light delay from Earth to Mars is significant enough that you're not going to teleoperate, like we do here on Earth, where a surgeon can operate on someone in Indiana, let's say from California. Now you're actually going to have to somehow train up these astronauts to do these very significant medical procedures on each other. So how do you train them? So there's a virtual reality aspects. How do you keep them from spacing one of their colleagues after 4 years or 3 years where you just can't take it anymore, right? So, the psychological aspects for it, how to keep people functioning and so forth, food creation, green walls, growing potatoes, which we all know is important if you're going to Mars, right?
Well, and one of the interesting aspects I would say is probably nutrition, right?
Yes.
Yeah, we all, food goes through a process in our bodies. Everyone
does.
It's the same process for everyone across the board, right? And so that's something that you got to think about, right? The right foods to eat.
The right foods.
Yeah.
And there's, large studies that go on of because you could also just eat protein bars and take vitamins, right? But you're not going to have a very functioning crew at that point. There's a human aspect to this. So how do you balance what you grow, what you take, ensure that if you had a crop loss, that's not a good time to have that be your only way of survival, right? Yeah. So how do you balance all of those nutrition intakes and how you're going to create the caloric and protein mass that the crew is going to need while keeping it, tasting good and all of that. So, you look at the sheer number of degrees and number of areas that start to get involved. It's pretty exciting.
That is fascinating for sure. And that leads me to believe the Martian, right? The movie, because we all know Hollywood is very factual based in aerospace. Gravity.
Lately, they've done better. Yeah, seriously.
Absolutely. Yeah. But one of the scenes that I'm most reminded about is the vegetation when he has to grow it, right?
Absolutely, right.
And so we're not that far from that kind of process.
Oh, absolutely. So I had the pleasure and honor of meeting Andy Weir, who wrote the book, at a couple of conferences, and of course he has a new one out now that focuses on the moon. But we were chatting about Mars, and he did all the math himself. I mean, it's real physics, it's real chemistry. It's very factual, and the Hollywood really tried to stick to that as tightly as possible. So all of those things that we did are spot on. We, the human race, did in the movie, and but then you get the debates of people that says, well, gosh, potatoes aren't the way to go. You need to grow strawberries or this type of lettuce. And so then it gets into a very healthy debate about, which of the pieces to take. But the technology exists as it is today. And, that's I was talking to somebody and I said, we are closer to Mars today than we were to the moon in 1961 when JFK gave us that challenge as humanity. He said, hey, look, we're going to get to the moon and back before the end of the decade. And if for Mars, the technology exists, we've had it for a long time, and it's how you stitch that together. And that's what I find really exciting about my job is working with NASA to say, let's not reinvent what we already have. Let's figure out how to use it and only invent the stuff that we still need to improve upon to get the mission executed.
Do you have any examples of the things that we need to improve upon?
There's several of them. When you look at, so we have Orion, which is what we call the command deck. So it's got avionics and the software and 5 flight computers and all the displays and so forth. So we don't need to keep inventing avionics and software. But we do need real regenerative, it's called, meaning regenerate the life support. Okay. So water recycling, we've actually done pretty well on space station. We want to go a little bit further. The carbon dioxide removal, keeping humidity from going on out of the spacecraft and so forth. So water and oxygen recovery and revitalization and regeneration is one key area. Another one is long duration, restartable, multi-year cryogenic propulsion. So that seems kind of technically detailed, but all it is you look at the space shuttle and you look at the that center orange tank that had oxygen and hydrogen. And when you put those together and you burn it, it's the best chemical propulsion that there is.
Right.
So right now we've got a lot of upper stages, but they don't have real long duration missions. We'll get a satellite up there into orbit, and then the upper stage, that propulsion is done. So we need to think of it as we need that workhorse locomotive that we can run for years at a time out to the moon and out to Mars and back.
Okay.
So that's the second one, propulsion.
Yeah.
Those are really the two main areas, that regenerative life support and that in-space deep propulsion is those are the two pieces that the technology exists. We just have to go engineer the hardware.
Absolutely fascinating.
Yes.
So tell me, Rob, why are you here today to talk at the Citizens for Space Exploration event?
It's so energizing for me to come out and talk to people about what we do. It's funny, I said STEM and I just kept on hauling on, and we wanted to stop and say, make sure everybody knows. Most people aren't aware of just how much NASA has going on. And, those of us that are in it day in and day out, it becomes so second nature.
Yeah.
So you come out and you get to talk to folks like the Citizens for Space Exploration that are, they're in every walk of life. They have day jobs that are not working at Lockheed Martin doing strategy. But when you tell them what we're doing, they are excited and supportive of it. And they're like, well, what can I do? Should I write my congressman? Should I send a note into the White House? And we're like, yes, absolutely, do those things so that the decision makers and the leaders continue to keep that momentum up that we've currently seen. So this is a great opportunity with the Colorado Business Roundtable that has sponsored this event with the Citizens for Space Exploration, and it's really just a chance to share what NASA is doing, what Lockheed Martin and Boeing and all of our subcontractors across the country, 200 businesses right here in Colorado, what we are doing to start moving humans on out into past the moon and on to Mars.
Yeah. Fascinating. I do want to let our audience know, we have mentioned this a few times, but those 200 companies that are associated with aerospace are 10 employees or less.
Oh, yes, absolutely.
Yeah.
Yes. It's very fascinating. There's companies over on the western slopes, for example, that do very precision hardware bracketry. And this isn't like just a bracket angle iron you might go buy at the local hardware store. These are highly optimized designs for weight, because every pound that we take up that's structure is 1 pound less of water or fuel or an astronaut. And so every pound counts. And so we work with these, I would really call them, and we've talked about it with them, they're really craftsmen. They are they're almost artists in some ways in some of these things that we have them do, which are typically, when we talk to them, the thing we're building or they're building for us is the most difficult thing that they're building within their company. It causes them to have to go out and buy new machinery or develop new skills, which in turn builds up our economy and our industrial base. And that's where, without getting a little too political, NASA, the money we spend, people talk about, well, why are we going to spend all this money in space? No. The money is spent on the planet Earth. Don't forget that, right?
Yeah.
And then we launch stuff into space, and every dollar we spend goes into increasing our industrial base, our capabilities as a nation, and our interactions with the rest of the world. So it's fun to talk to these really small companies that have very key critical skills. And, Lockheed Martin doesn't have that skill, and it doesn't make financial sense for us to try to go develop it. You go partner with somebody who can build it for you, and it's really exciting. And we'll take some astronauts in, and we'll go and visit their employees, and you talk about getting pumped up.
Oh, wow. Yeah. Oh, so you didn't bring an astronaut here?
Did not bring an astronaut here.
I will forgive you for that. That's quite all right. But I do want to ask you, that is one question that I have gotten on the trend of asking. So you have a great title here, Strategy and Business Development for Human Spaceflight, both. If you could pick a career within aerospace that is not that, what would you choose to do?
Astronaut.
Immediately.
Oh, absolutely. Yeah, no question.
Yeah. So did you try for that?
I did. I like all of us, you started at 5 years old and said, I want to be an astronaut. And then you went through, I want to be a policeman and a fireman and a dentist and a garbage man. And then you go back to, I think brain surgery was in there for a little while.
I just wanted to be a mermaid, I'll be honest, and maybe a rock star at one point.
Well, you combine all those, because you kind of swim through space if you're an astronaut, and you're definitely a rock star when you do that. So yeah, all the way through high school, I applied and so forth, and then in the end realized that my strengths are in the engineering and the design of the spacecraft, and so you get really comfortable kind of finding your calling, and then figuring out how you can contribute to what's fundamentally changing the course of human events, right?
Right.
The knowledge of whether there's life out there, and getting humans out to allow us to more effectively explore Mars, and then get boots on the ground, and then set up shop there. Those things fundamentally change us as a species, and so any way you can contribute is really life-changing for everybody else, but also for yourself.
Yeah, fantastic. This has been a great conversation today. Thank you so much, Rob Chambers, for joining us.
Thank you for having me. It's great to be able to talk about what we do.
Yeah, absolutely. So if you are stuck in traffic and you're listening now, don't forget to stop by 4100 Jackson Street. That's near 40th in Colorado. We are having the Citizens for Space Exploration event. Here this evening, you can hear Rob Chambers tell his story live up on our stage. And be sure to check out this podcast tomorrow at cobrt.com/radio. Thank you again so much, Rob.
Thank you.
It's been a pleasure. Have a great day. We will see you.